Okay, so good day, grade 8 math science students. So for our lesson for today, this is going to be our fifth module for the third quarter. Our lesson is going to be AAA, SAS, and SSS triangle similarity theorems, or the angle, the three angles, the side angle side, and the side triangle similarity theorems. So when we say similarity theorem, it's quite different from congruence. Okay, so as you've noticed, and also as we have discussed in our previous discussions, okay, one of the most noticeable symbols is for their relationship. Okay, the relationship of the polygons using congruence. So this is the symbol for that, and for similarity, this is the symbol. Okay, so let's try to answer one of the preliminary activities that we have. So post-COVID-19, when the Filipinos were moving forward from the effects of pandemic, you came home from school still with a face mask on. As you were walking home, you noticed an orange cat stuck on top of a tree, meowing incessantly. There was no one around to help the cat. With your tree climbing expertise, you were able to nimbly climb the tree and save the cat. Since she was a stray cat and was wounded, you adopted the cat. So consider the following illustration below. Okay, so we've formed a triangle here. Okay, triangle KAT. Okay, and we want to know the measurement of. Okay. So you want to know the measurement of the height, okay, the height of the tree from points K to A. Okay, so you want to know the measurement of this one. Given that, okay, so given that TA is 15 meters and given that TK is 8 meters. So you want to know the measurement of AK. So how do we do that? Since we can draw a a right triangle here, therefore we can use the Pythagorean theorem to solve for the value of AK. So AK squared is equal to TA squared minus TK squared, and AK squared is going to be equal to 15 squared minus 8 squared, and 15 squared is simply 225. Let's just double check. Okay, 225 minus 64. Okay, so 225 minus 64, that will give you 161. And what's the square root of 161? Square root of 161 is 12.69. Okay, so that's the height of the tree, 12.69 meters, or the trunk. Okay, so it's not the tree itself, it's the trunk from points A to K. Okay, so if we extend, the segment TK to point E, we will have formed two congruent triangles. Okay, so this becomes TAK, and then we have your point E. Okay, so for number 3, okay, how can you make the two triangle for number 2? Still for number 2, how can we make the two triangles congruent? By, of course, if this is if TK measures 8 meters, then KE must measure 8 meters as well. And if this is 15 meters, AE must also measure 15 meters as well. And since the two triangles share the same side, so that means they have a side that they share that measure 12.69 meters. Okay, so using the SSS, okay, so the three sides are congruent, using the SSS triangle congruence postulate, there you go, we can say that the two triangles TKA and EKA are congruent to each other. Okay, there you go. So two triangles can only be similar. So for the first figures that we had, those were congruent triangles. But for this one, we're going to be discussing about similar triangles. So as what we have discussed from similar polygons, similar polygons can only be similar if and only if, number 1, their corresponding angles are congruent. Okay, so they're congruent. And number 2, their corresponding sides are proportional. So what does that mean? Okay, so again, this also applies for all types of polygons, and since a triangle is a polygon, it means that it also applies for triangles. So there you go. For example, we have here triangle AYE. Okay, we have here triangle AYE and triangle RGN. Okay, triangle RGN. So we can see here based from the markings, that their corresponding angles, angle A and R are corresponding, they're congruent. Angle Y and angle G, they're corresponding and they are congruent. And angle E and angle N, they are corresponding and they are congruent. So we have satisfied the first prerequisite, or the first prerequisite for two polygons to be similar. The second one is their corresponding sides should be proportional. So that means AY all over YE should be equal to RG, RG all over GN. Okay, so what does that mean? So 20 over 18 should be equal to 10 over 9. And as we can see here, based from this proportion, that 10 over 9 is equal to 10 over 9. And therefore, the sides of these two triangles are proportional to each other. And therefore, triangles AYE and RGN must be similar triangles. Okay, so Sir JM, what's the difference from that from a congruent triangle? Congruent triangles, all of their side measurements must be the same. Aside from their angles being the same or equal to each other, their side measurements must be the same. For this one, for similar triangles, so the sides can be different from each other, they just have to be proportional. Okay, but for congruent, they have to be the same. So for example, if this is AYE and the measurement of their sides is 20 by 18 by 24, then the triangle RGN must also have side measurements of 20, 18, and 24 in order for them to be congruent triangles. But since we are only looking for their similarity relationship, so there you go, their side measurements are not really congruent, but they are proportional to each other. So as with the 4 triangle congruence theorems that we discussed during the second quarter, for the third quarter, there are 4 triangle similarity theorems. So there's the AAA, the angle, angle, angle. So it means that if three angles of a triangle are similar, two triangles are similar if and only if their corresponding angles are congruent. So that means if the 3 corresponding angles of one triangle is congruent to the 3 corresponding angles of another triangle, then the 2 triangles are congruent using the Aaa Similarity Postulate. The Aaa Similarity Theorem states that if only 2 corresponding angles of one triangle are congruent to another triangle, then the 2 triangles are similar. Then similarly, so we have the Sss Similarity Theorem. So if the corresponding sides of 2 triangles are proportional, to the sides of another triangle, then they are similar. Then the side angle side, if in 2 triangles 2 pairs of corresponding sides are proportional, then and also the included angles are congruent, then the triangles are said to be similar to each other. Okay, so we have here a proof for the Aa Similarity Theorem. So we have here 2 triangles, triangle FLA, and triangle FLA and OCA. Okay, so we can say here that since angle L and angle C are congruent to each other, and this angle at the center, so we have this angle at the center, angle FAL and angle OAC, since they are congruent to each other, so angle FAL is congruent to angle OAC. So therefore we have 2 triangles that are congruent using the AA, similar 2 triangles that are similar to each other using the Aa Similarity Postulate. So therefore, if we use the symbol, we have this symbol right here. Triangle FLA is similar to triangle OCA, or triangle FAL is similar to triangle OAC. Okay, there you go. Okay, so for the second one, we have here this Aaa Similarity Postulate. So let's try to prove it using a 2-column proof. Okay, so for the first statement, we have your given. Okay, so let's make the font much more smaller. Okay, so we have your given angles U and I are congruent, and also angles F and M are congruent. Okay, so we can write that as our given. Okay, so that's a given. And number 2, we can write here that since we have your measure of angle U, okay, plus measure of angle I, since they are congruent to each other, would be equal to the measure of angle F plus the measure of angle M. Okay, so that will give us, okay, number 2, the reason for that can be the angle addition postulate. And what can we notice with our two triangles? Okay, so as with all triangles, the measurement of the interior angle the total interior angle measurement of all triangles is equal to 180 degrees. So we can write here measure of angle F plus measure of angle U, okay, plus measure of angle L is equal to 180 degrees. And also we can say that for the measurement of angle I plus the measurement of angle M plus the measurement of angle N is also equal to 180 degrees. Okay, so the reason for that is the sum of interior angles of a triangle is 180 degrees. And what we can see here, guys, we have here 180 is equal to 180. Therefore, we can say here on the number 4 that, okay, so let's just simply copy this one and paste it here. Okay, and let's try to make it, let's try to make this one the number 4. Okay, so this is the 4th one. Okay, so this becomes this. Okay, so this one is going to be equal to this one. Okay, so they're going to be equal to each other using the transitive, okay, using the transitive property of congruence. Okay, transitive property of congruence. Okay, so that's number 4. Okay, so since we have here that the measurement of angle F and angle U, when we add them together, they're congruent to angle I plus the measurement of angle, okay, angle M. Okay, so we can say that number 5, we can say that the measurement of angle L, okay, is equal to the measurement, okay, is equal to the measurement of angle N. Okay, and that will lead that angles L and N are congruent to each other by using the substitution property and the subtraction properties of equality. The substitution and subtraction properties, okay, properties of equality. And therefore, we can say that, we can say for our 6th statement, okay, so right here, number 6, that triangles UFL and IMN, okay, IMN are similar. Okay, so they are similar triangles, or if we can write that using a symbol, okay, UFL is similar to IMN. Okay, so those two polygons are similar to each other using the AAA, okay, using the AAA triangle similarity theorem.